So this is a breadboard that I have of a ALU, an 8-bit ALU, and I never have anything to point with. This is two chips, an LS381 and an LS382. It could easily be two LS382s. It's just that I have more LS381s than I have 382s. So the 382 has the simple carry ahead, so it's easy to wire up. The ones that have the predictive carry ahead are a bit more difficult to wire up and use. So that's how this is set up. Anyway, I have two registers. I have an 8-bit register A, 8-bit register B, and then I have the resultant here on some LEDs. So I can put a value in the A register of 1, and I have the operation code set to 011, and 011 is A plus B. Okay? So we have 1 plus 0 is 1, 1 plus 1 is 2, 3 plus 1 is 4, 7 plus 1 is 8, 7 plus 3 is 10. So it does a simple addition. If we want to do subtraction, let's see. A minus B is low, high, low. So low, high, low. This should be a subtraction. So if we put a value of, let's say, 7 over here, and we have 0 over here, 7 minus 0 should give us a 7. When you do subtraction, you have to set the carry in bit to 1. When you're doing addition, you have the carry in as 0. So we'll set the carry in to 1. So now we have 7 minus 0 is 7. 7 minus 1 is 6. 7 minus 2 is 5. So there you go. So this is the S012 registers, and we can set that to anything we want. We can set it to a clear condition, all low, sets the output to 0, and if we have them all high, it should preset the output all to 1s. And there they are, all set to 1s. So we can do exclusive ORs and other things like that, but this is the basic circuit. You can see it's a bit flaky, right? If I push on the wires, everything goes a bit crazy. These things are really difficult to manage. They're just kind of a pain. That's what kind of said, well, wait a minute, I need to do a PC board. And you can see from my layouts, this will end up being quite small. It'll be one of the few boards that have through-hole parts because nobody ended up making these in a surface mount package. So that's the idea of an 8-bit ALU. So it does require two chips. It does require us to be able to set the carry bit. So that's an additional input to the system. So we have 8 bits in, but we also have a carry in. There'll be an output also. There'll be a carry out that we're interested in. And then if I expand this to add the HC85 chips, which are the compare chips, there'll be 2 additional chips. These additional chips will do a compare, and they will compare these 2 values, and they will give 3 flags: a less than flag, an equal flag, and a greater than flag. So we'll have 2 flags coming out of the ALU card: the carry, less than, equal to, greater than, and we'll have 1 coming in for the carry and 3 coming in for the mode. I have a clever way, I think, if it was going to work, a clever way of getting the mode bits in without having to complicate the instruction set microcode. So we'll see if that's going to work or not. Anyway, there you go.